Okay, so now we're in a period of the most rapid warming since the last ice age. One major consequence is that about 80% of species have moved towards the poles since 1970s. However, such movements can't guarantee their survival if they're not able to move fast enough to keep pace with the moving temperatures, especially for those relatively immature tree species. Well, actually, massive shifts in the distribution of trees have occurred a few times during the past glacial-interglacial transitions. Here are a few illustrations showing the migration pattern of trees in North America following the retreat of the ice. This is basically how long ago spruce and oak came back north. 21,000 years ago, 17,000 years ago, and 11,000 years ago they reached Canada. Now, polar records like this show that most tree species were able to track climate change in the past. However, today they are facing a very different situation. Due to our increased urbanization, future tree migration will have to overcome substantial anthropogenic barriers. Cities. In previous eras, trees gradually shifted their range so an uninterrupted landscape. But now they're facing agricultural land, buildings, highways, and other infrastructure. These are the things that they didn't have to deal with in the past and will greatly reduce their migration rates or even leave them stranded. So how can we help these climate refugees? Or in other words, how can we make cities more permeable to these ecological processes? And that's what I'm going to talk about in this presentation. My name is Xiao Han. I'm a postdoc at Queen's University Belfast, working with Professor Greg Keefe. So we know that building green corridors like this is often suggested to be an effective strategy for species migration because it could provide large continuous natural areas that allow species to move from one habitat to another. However, in cities, it is often hard and sometimes impossible to create such linear landscapes, especially across high-density residential areas or city centers. And since trees move as individuals rather than communities, different tree species will move at their own rates and along their own trajectories. In such cases, we will be talking about building more than one or two corridors across the city. So the strategy of green corridor is not very practical here. Now, it looks like a dilemma. We can't have continuous green urban areas without restricting the movement of trees. We can't create continuous green areas for trees without reducing the compactness of cities. So what are we going to do? Well, basically, the mechanism of forced migration is different from animal migration, because obviously trees can't move on their own. Instead, their movement depends on dispersal of their babies, seeds. They take a long time, sometimes even 30 years or more to start producing seeds. But seeds don't move on their own either. They rely on the wind or animals like birds or squirrels to move around. Now, birds are very important dispersal agents for forest trees because they can carry seeds for very long distances. And this gives us an idea. Since birds could fly, they don't need to physically connect the landscape to support their movement. What they really need are stepping stones, or more specifically, a network of stepping stones. From this perspective, our highly modified and fragmented landscape in cities actually have the potential to act as stepping stones. For example, even something as simple as planting a tree in your own garden might aid the activities of birds. However, even though biologists and ecologists already did fantastic work in studying the importance of stepping stones, they almost never take into account the landscape in cities. So we thought it would be interesting to take some of the lessons that scientists are learning and use them to help us understand the biological benefits of urban landscapes. So our first project with respect to this was to add stepping stones in Greater Manchester to improve urban permeability to forced migration. In Greater Manchester, we identified private gardens and street trees as a potential sites for tree planting. As I discussed earlier, the migration trace depends on the foraging activities of birds. So we assume that urban areas with a higher frequency of visitation by birds would be more permeable to the migration trace. The problem, however, is that observing the foraging activities of birds is not always feasible in urban areas. It could be very challenging or frankly just impossible to do such a thing in a metropolitan area. So if we're going to assess permeability, we're going to need a new way of measuring the abundance of birds without actually counting their numbers. And ideally, it should be extremely generic so that we can use the same measurement method for lots of different dispersal agents. So here what we figured out was an idea to exploit an observation in biology. That is, the occurrence of birds is influenced by the accessibility of landscapes. Urban areas that have more accessible air dispersal network usually have a higher frequency of visitation by birds. Here, thickness of line indicates the frequency of movement. So if we're able to measure the accessibility of urban landscapes, we don't need field-based observation data of birds. To achieve that, we mapped the city's personal network of three bird species in Greater Manchester: UGGs, UG16s, and coatis, based on their flight distance. We then applied space syntax to measure the frequency that a dispersal path is located in the shortest routes between all pairs of patches. As shown in the figure, the stepping stones formed by garden and street trees create a large number of dispersal paths, which greatly improve the urban permeability by more than 400%. We also calculate the proportion of trees to form stepping stones in different residential density areas. In general, trees planted in high density residential areas appear high degrees of aggregation and thus have a relatively high potential to form stepping stones. Finally, this presentation just focuses on one aspect of the research. If you're interested in more details, please refer to the paper. The argument I'd like to make is that urban landscape should be seen as a network. They have some kind of properties that cannot be understood just by studying the individuals. We believe that a network-based perspective can be incredibly helpful for designers to understand how urban landscape function and to devise smarter solutions for climate adaptation. Thank you very much.